Hi and welcome to the 2018 Paper 1 of the Junior Cert Higher Level. This is question 13 we're on. And as usual, if you want to set the notes I'm working off, please send me an email at shanetroy@gmail.com. And that email address should be in the description below. So question 13 has two parts. It's worth 15 marks. It says below are four statements about three non-empty sets. That's important. Okay. P, Q, and R in a universal set U. Now part A there says put a tick correct in the correct box, or put a tick in the correct box in each case to show whether each statement is always true, sometimes true, or never true. And just gives an indication of the symbol there. P complement is the complement of the set P. Okay, everything outside of P. Now part 1 there, we have to justify that later on, but that symbol there means the number of. So the number of elements in P union Q, or P and Q joined together, is equal to the number of elements in P plus the number of elements in Q. Now, I find this kind of question incredibly hard because it's hard to visualize what's going on. For part 1, and in order to make the statement, I would suggest that you pick an example. So I was going to go and flick on a few pages, okay? And I have the justification down here. You see that'll hopefully make sense. So the answer for that one is it's sometimes true. Okay, for the simple reason that if you pick values of P and Q, and let's say I have the sets 1 and 2 and 3 and 4. So there's no commonality in these sets. Okay, is the number of sets in P and Q joined together is 4. Okay, is that equal to the number of elements in set P, 1, 2, and Q, 1, 2, so 2 and 2 is 4. So it is, okay. But if you have a different set here, where there's overlap, okay, 1 and 2, and 1 and 4, so P union Q joined together is 1, 2, 4. That's 3 elements. Whereas if you're getting the number of elements in P is 2, and Q is 2, so it's 4. So it's not true in that scenario. So it's sometimes true. Okay. Now the second one here, I was going to go back a step. It says there P less Q means P take away Q. Okay, so let's identify that first. Okay, so I've actually put in two sets here of P and Q. So P take away all of Q. Okay, that's what we're talking about. Is that the same as P intersection Q? Okay, I'm just going to use this part of set. P intersection Q is the middle bit here. Okay, are they the same? No. Okay, that's where we got. So we go back, and it'll never be true, no matter what the elements are. Okay, now I'll get rid of this here. I'll just use this down here a bit faster. So if I start again, now this one is P intersection Q. Okay, complement. So the middle bit between P and Q, everything outside that. That's what we're talking about here. So that's the middle bit, P intersection Q. We are talking about everything outside of that. Okay. Now, is that equal to P complement everything outside of P? Okay. So everything outside of P would be like all of this here. Okay. Now, and combined with everything outside of Q. Now I'm going to use a different color here. Okay, we can get the color work. It's red or whatever. Everything outside of Q, which is all of this. Okay. Okay, it is. Okay, so that middle bit, that's always true. Okay. So yes, always true. Okay. Now the last one here is 3 sets. Okay, now just for the last little bit here, I'm going to use these the 2 sets here. So it's the fourth statement is saying, now we do inside brackets first, so Q union R, sorry, Q intersection R. That would be Q intersection R is this bit here. Joined with P. Okay, so P union that section. So P joined with that section is all of this. Okay, now is that bit that's highlighted there, is that equal to, sorry, get it right, Now you do inside the brackets first. I'm going to use different colors here, but P union Q would be all of this joined together. Okay. Now P union R is all of this joined together. Okay. And the intersection of those things, where those two things are joined together. Okay, let's give that a go again. So I just brought in just a different infographic to help explain it. Okay, so we're doing say brackets first. So Q intersection R. Okay, like we said before, is Q intersection R is this bit here. Okay, the commonality between Q and R. Now P joined with that, okay, is all of this here. Okay, so is that the same as, now we've got to do inside both brackets, so P union Q, okay, is all of this joined together, okay, so let's put lines to it just so I don't destroy it, okay, all of that, okay, P union R, now I need a different color here to try make this stand out, P union R, okay, so we'll go this way, P union R, okay, so it's all of P and all of R. And the last thing there is the intersection between those things. Okay, so the commonality between those things is a bluish color. Okay, so where has yellow and black? Okay, where's all of that there? Is the blue, whatever color it is on colorblind stuff, is whatever color that is that equal to the black here? Yes, it is. Okay, now that's always true. Fairly complicated. Okay, now I've put in here in the notes just certain things about sets, okay, and some of the different terminology, but it's probably worth making sure you're au fait with what's in the book and the terminology that's there. That'll be more likely to be what's asked. Some of the stuff here at the bottom may not be too commonly asked. There's lots of things online about lots of other videos. If this isn't making as much sense, maybe as it should. But anyway, that's question 13, and see you on question 14.